Right. Welcome back. It is now November 19, time of recording. Today we'll be handling tong mazes. Right? Kaka-unlock lang natin yun. Right? Mazes, and then if may time tayo tong dinosaurs, pero I doubt it. Tingnan natin kung may oras pa tayo after nun. So tong mazes, para makapag-generate ka ng maze, kailangan mo tong weird substance. Right now, ginagawa naman natin yun. Right? Actually, maglagay tayo ng guard nun. It was false. Kasi kapag gumamit siya ng weird substance sa bush, posibleng gumawa siya ng maze. So, ayaw natin mangyari yun. Play natin ulit to. So anyway, right. Mazes. Para makapag-generate ka ng maze sa game, kailangan mo mag-plant ng bush and then gagamit ka ng weird substance. Ito yung amount para sa buong farm. Right? Sometimes gusto mo mas onte kung gusto mo mas maliit yung maze. Pero ito yung formula for the whole farm. Okay? And then, may wording din dito, mazes do not contain any loops. Unless you reuse the maze. So ano meaning nung do not contain any loops? Right? And ano ba yung significance nung reusing ng maze? Right? So, nag-fail ako kanina. Hindi ko ito na-record. Right? So, imagine mo may maze ka dyan. Right? Ito yung maze mo. So, magmumukhang pirate software ako dito na I'm using a whiteboard to goddamn explain. Right? I do apologize. So, parang ganun. Right? Sabihin natin may maze ganyan. Some random maze. And then, ito yung target mo. And sabihin mo nag-start ka dito. Right? So, one strategy kasi na pwede mong gawin is hug mo yung isang wall. Right? So, for example, dito, mahag tayo ng right wall. So, hug natin yun, di ba? Parang may kamay ka, hinahawakan mo yung pader sa right. And then, maglalakad ka lang. Right? So, maglalakad ka, iikot kang ganyan, ikot kang ganon. And then, gaganyan ka. So, imagine mo nakahawak ka pa dyan. Right? Sa right wall na yan. No? And then, dead end, uulit ka na naman. Right? So, aandra lang to kapag walang loops yung maze. I'll show you in a bit. Right? So, imagine mo nakahawak ka pa sa right. Miss mo yung treasure. Right? Hawak ka pa sa right. U-turn ka. No? And then, eventually, maabot mo tong treasure. Tapos ka na. Right? And kung tutuloy ka pa dyan, right, kung itutuloy mo to, babalik ka sa position mo and you have fully traversed almost every, or if not every cell ng maze, right? So, gaganyan ka. So, imagine mo nakahawak ka pa rin sa right wall, right? So, that's a very useful algorithm, right? Yung paghug mo ng right wall. Okay? Now, kapag nireuse mo daw yung maze, oh wow, bago to. I think dati wala yan. Yan, you can also reuse the maze by using the same amount, right, of weird substance on the treasure again. So, magra-randomize yung position ng treasure. And hindi naman fully blind yung bot mo. Alam niya kung saan yung treasure. May XY. Right? Pwede ka mag-measure. Anywhere. And then makukuha mo yung XY. And every time nag-move yung treasure, may mawawalang pader. So, pwede siya mag-contain ng loops. So, ano meaning ng loops nun? Right? So, kunyari na-collect mo yung treasure dyan. Right? Balik tayo dun. Let's say na-collect mo yung treasure dyan. And then, nag-start ka na naman ulit. Okay. Let's say nabura to. Itong area na to. So sabihin natin nabura to. Itong section na yan. Right? So, magpa-fail yung right wall hugger mo. Right? So, to show you that, sabihin natin naka-right wall. Oops, my bad. Naka-right wall ka dyan. And then nakaharap ka sa taas. Right? Sa north. And then ikot kang ganyan. Right? And then pagdating mo dito, wala, babalik ka na dyan sa island mo. So, parang may maliit ka na island dyan. Right? And then babalik ka dito. And then wala na. You are contained in this area. Right? Hindi ka na pwede mag-right wall hug. Right? So for today, we will handle ito some of my own solutions. So what we will handle here is right wall hugging, right? So that's one way of solving it, right? Number two is if we have knowledge of the maze, right? And if we have time, of course, let's try solving it via BFS. Or we're also going to try like modifying this. Gagawa tayo ng parang mala A-star, right? Dahil alam naman natin yung position, right? And most likely we can do a heuristic, right? So yeah, let's get into that. No, hopefully you could bear with this episode. Right, so gagawa tayo ng bagong file. Right? And check natin to saglit, baka may naiwan pa ako. Right, can move, that's new, I think. Right, don't quote me on that. I don't remember using this sa past playthrough ko. Yeah, note that loops can make it much difficult. Yeah. Right. Reusing a maze, does it give you more gold? Right. Yeah, 100% optional lang siyang. Right, so pero we are going to try it kasi it's much more efficient na mag-reuse tayo ng maze kesa sa nag-figure out tayo ng panibagong maze. Right. So I'm gonna make one here. Def solve maze. Right. Args equals none. Right. And then una natin gagawin is generate maze. Just clear everything. Right. So kung may pinlant tayo, kawawa na lang yun. Right. Pero for now, we're going to just let that be. So travel to point fastest. Right. Import natin yung navigation. Travel to point fastest, yung center. Right. So I do believe ayun, inassign natin yung half world size there. Itong nandito, right? So use item substance, right? So this should generate the maze, right? Now, gawa tayo ng if main, solve maze. So let's just test muna ngayon kung nag-generate siya ng maze, right? So gumawa siya ng maze, ayan, right? Now mag-implement tayo ng right wall hugger. Right. And it's not actually that hard na i-implement natin to. You might think na parang intimidating siya at first. Pero I'll teach you a technique when you're traversing yung mga ganito, yung mga grid-like na spaces. Right. Ito, XY lang naman to eh. Right. So north, west, right, east, south. And it might be even harder kung 3D yan. Right. Pero right now, 2D lang naman to. So not that bad, I'm not gonna lie. Right? So comment out natin to si generate maze para di siya mag-generate ulit. Right? And then gagawa ako ng mga arrays na very important. Right? So una gagawa tayo ng tawag dito. Gagawa tayo ng arrays. Right? So direction array. Dear array. Right? Gagawin ko tong tuple. Right? So meron tayong north. Meron tayong south. Gagawin natin clockwise, by the way. Gagawa tayo east, south, and then west. Okay. So, meron tayong directions from north clockwise. And then yung matching na right wall nun. Right? So, right wall array. Right? So, that will be east. So, if you're facing north, right? Sabihin mo nandito yung bot. Facing siya north. Yung right wall niya is nasa east. Diba? So essentially, nagdagdag lang tayo ng step dyan. Right? You can also reuse this and then mag +1 tayo. Right? Mag +1 tayo na index. Pero I think okay lang din naman to. No worries. Right? West and then north. Right? So tama, pag nasa west ka, pag nakaharap siya sa west, yung right wall niya nasa north. Diba? So now we can actually solve that na. Walang problema. Right? What we'll do here is magwa-while loop tayo, right? So while true, uulit-ulitin ito, right? Gagawa tayo ng current direction, by the way. Current direction natin will be 0. So you might think, okay, north, whatever. Pero it will be 0 kasi mamatch natin tong array na to. Right? So kung nakaharap siya sa taas, yung current direction niya 0. Kung nakaharap siya sa west, yung current direction niya 3. Right? So while true, right? If can move, kung makakagalaw siya dun sa right wall niya, ikot siya pa right. Right? So right wall array, and then yung current direction. Mag-move siya dun, first off. Right? Actually, gawin natin ganito. Right wall direction. And then i-rematch natin ganun. Mag-move tayo to that direction, and then i-update natin yung direction as if nag-move siya to the right. So to do that is current direction is equal to, pwede bang mag-modulo equal dito? Yeah. Modulo equal, nope, hindi pala. Current direction plus 1, and then modulo natin yung 4. Right? Kasi magiging cyclic yan eh. Right? So, bakit may modulo 4? Right? So imagine mo nasa 3 na siya, nakarap siya kay west, and then magta-turn siya ng right. Right? So magta-turn siya ng right, pupunta siya kay north. Para bumalik siya kay 1, right? Magpa-plus 1 siya, wala naman tayong 5. Ay, wala naman tayong 4th index or 5th element. Right? So babalik siya kay 0. Right? Ganun tayo gumagawa ng parang cyclic stuff. Nagmo-modulo lang tayo. Right? So current direction is yung current direction plus 1, modulo 4. Right? Ma-update siya nun. Okay? So if we try this out, right? Actually, kapag di siya makakagalaw, kung can't move, right? Kaya ba niya mag-move to the forward direction? Dear R. Current direction. So, kung kaya niya mag-move dun sa forward direction niya, right, then mag-move siya sa forward direction. And we don't do anything. Otherwise, right, kailangan niya mag-turn left. Right? You can also argue na parang, hayaan ko lang to, and then nag-update ko lang yung direction. Right? Which is also, which would also work. I'm not gonna lie. Right? So, we can actually just do that. No, to just show you. So, current direction, so instead of turning right, so for example, nandito yung bot natin. Right? Nakaharap siya. And then magra-right siya. Ayaw. Move forward, ayaw. Kapag nag-move left, pwede natin i-separate check yun and moving backward. Pero I think it might actually be simpler on our end na u-turn na lang natin siya kaagad from this direction. Right? So, it will start facing in the reverse. Kasi yung next check niya, right wall na naman ulit. So, makukuha niya tong left. And then forward. Right? So, it's as if kalahati yung... Well, I hope you get it. I hope you get what I mean. Right? So, current direction is equal to same lang na ito and then plus 2. Right? So, mag-u-turn siya dyan. So, we can try this kung nag-work. Right? Makita natin kung matatraverse itong maze na to. Right? So, yan. Right? It might be too fast, right? Pero I do see it working. Yeah, I think I do see it working. Yeah. Okay. So that's one way of solving this, right? And then before everything else, right? If get entity type is equal to entities.treasure, right? You harvest it, right? And then tapos ang laban. Okay? So let's go ahead and try that, right? Okay? So nagka-gold na tayo, right? And we can try again. Let's go ahead and uncomment tong generate maze. Play. Okay? Another try. Another try. And ayun. Ganun lang kasimple yung right wall hugger. And pwede mo itong i-modify din to pwede mo rin siya i-modify to hug the left wall or something similar. Right? But in our case, we're going to try reusing yung maze. Right? So, pupunta tayo sa step 2 nito. Right? Yung BFS muna, then yung A-star. So, how do we do that? No? This is a very weird introduction sa graph theory. Right? Kasi, or sa graph algorithms. Right? There might be a simpler introduction somewhere else, pero I think this is very fitting to explain it to you, right? So for example, may graph ako, right? Let's make it small muna. Right? Sabihin natin 3x3. May graph, may grid ako, sorry. And then sabihin natin may maze tayo dyan. Let's say something very simple. Ganto. Right? Para ma-represent natin to sa data, kailangan natin to i-represent as a graph. Right? So yung graph, meron kang nodes, tsaka meron kang edges. Right? Sometimes yung nodes, tinatawag din yan vertices. Ako, I myself, I use them interchangeably. Right? Vertices, plural yan ng vertex, by the way. If you're wondering. So, yung vertices mo, essentially, ito yung mga dots. Right? Itong mga edges mo, ito yung mga lines na nagko-connect dun sa nodes mo. Right? And yung isang graph, it can be directed or it can be undirected. So, wala siyang direction. So, for example, mayroon akong maliit na graph na ganyan. Ito yung isang example ng undirected graph or something simple. Right? And you also have a directed graph. No? Na kunyari, one way lang. One way lang yung connection. Or can be two-way na parang dalawang directions like that. Right? And another way of thinking about it is weighted din yung graph. Pwede ka maglagay ng values dun sa edges. Right? Na kunyari 4, 2. Right? Itong kanina yung example natin, unweighted yon. That means lahat ng edges uniform weight or no inherent value yung weight ng isang edge. Pero here, this is useful. Kunyari, minamap mo yung let's say Maynila. Right? Di ako taga Maynila. I mean NCR. No? Sabihin natin may mabilis na expressway dito. And ito may mabagal na daan. Right? Sabihin natin ito yung mabagal na daan, kulay red. Right? So instead of like adding more nodes para mag-denote ka na matraffic siya. Right? Maglalagay ka na lang higher weight versus ito na parang kunyari yung 2. No? Even though parang same distance lang sila. So that's one use ng mga weights sa isang graph. Right? Pero for now, we can settle with a bidirectional graph or a undirected graph na walang weights. Right? To represent this. So to represent it, right, let's say ito, bawat grid, bawat cell natin dito is isang node. Right. So bawat cell natin dito isang node. And kung pwede tayo mag-travel, i-connect natin sila by an edge. Right? So may parang ganyan ka. And yung pinaka-graph representation nito is kung iisipin ko siya, meron tayong 3, 4, 5, 6. Then something like this. Right? So parang meron kang graph na ganyan. And how do you store this sa isang program? Yun yung tanong, di ba? Right? Paano mo store? And there are multiple ways of storing this. Right? I'll give you like 2 popular implementations. Ako, I personally use yung adjacency list. Right? So, bawat cell natin dito may unique identifier denoted by XY. Right? For example, ito, i-green natin para hindi nakakalito. Right? Ito 0, 0. Ito 1, 0. 2, 0. Right? Ito 0, 1. Etc. Right? So, gagawin natin dito to 0, 0. 1, 0. Right? May names yung ating mga nodes. Let's say, itong nandito, example lang naman, don't match this to the graph above. Sabihin natin to 2, 0, and then 2, 1, right? And then to 1, 0. Something like that. So, para ma-represent mo to, meron kang key dun sa dictionary mo, right? Which is 2, 0, right? And then yung adjacent sa kanya is si 1, 0 and si 2, 1. Right? And then pwede natin i-iterate yan eventually. So, lilista mo lahat yan. Lahat ng mga nodes sa graph mo. Right? Ako, I will personally use this. Another way of doing it is via an adjacency matrix. Right? Para lang aware kayo sa ibang implementations ito. Right? So, adjacency matrix, may matrix kang ganyan. Right? Matrix, by the way, isa siyang 2D na data representation. Right? May matrix kang ganyan. Let's say, meron kang graph dito. Right? Si A, si B, and si C. Right? Sabihin natin ganito. A, B, C. A, B, C. Right? Itong nasa gitna doesn't really matter. Right? So sabihin natin si A tsaka si B magka-connect. Right? So bibigyan natin ng value yan. Right? Si B tsaka si C hindi sila magka-connect. So 0 natin yun. Right? Ano ko bakit nag-red? Dahil bang may background. And si A tsaka si C magka-connect. So may value na naman yan. Right? So pwede ka rin mag-traverse ng graph through this. Right? That's also another option. Right? So, yan yung mga data representations ng graph. Right? So, i-implement natin yun ngayon. Right? Para makapag-reuse tayo ng maze. No? Una, for utility's sake, feed treasure. Right? Or feed substance. Oops. World size. Right. So, gagawa tayo ng adjacency na list, right? So, add list. Or pwede natin gawing graph, right? Which will be a dictionary, right? And pwede natin tong i-initialize with the empty arrays for now. So, for x in range, let's say, so pwede natin tong ibahin din. Yung args, gawin na natin to size. Right? If size none, size equals get world size. Right? For x in range size and for y in range size, right? What we'll do here is may yung graph natin. Ito yung magic kay Python, di ba? I'm sure I mentioned this before. Pwede natin gawin key yung tuple. So xy, right? And then empty list, right? For now. So kapag pinilit mo tong graph, empty pa siya. Yeah, and then pwede tayong gumawa ng visited graph din, right? Pero I will hold off on that for now, right? So, may graph tayong ganyan, right? Paano natin papopulate yung graph? Okay. So, una, hindi tayo mag-harvest. Right? That's a bad idea, mag-harvest tayo agad. Right? Kasi gusto natin i-explore yung maze muna. Right? Kasi what happens is, kunyari, nandito tayo sa gitna, di ba? And then, nandito yung treasure. Pumunta lang siya doon. Never natin na-explore yung buong graph. right? And hindi niya alam yung gagawin. So, explore muna natin siya right now, right? So, if Ken move siya sa right, magpapaturn kasi natin siya sa right, di ba? Right? And what we'll do here is we get the current position. So, current X, get pos X, and then current Y, get pos Y. And then gagawa tayong origin din. Kasi kapag bumalik siya dun sa original position niya, right? Sabihin natin here, right? Kapag bumalik siya sa sarili niyang position, alam nating nakapag-traverse na siya ang isang buong branch ng path. Not necessarily yung buong maze kasi pwede ba siyang may ibang valid direction right? Pero that's a good marker for a maze without loops, right? Na-explore na natin, right? So, yeah. So, store natin yung origin point. Right? Same way. Get pos X. Right. So, while true, alam niya yung current niya. Kapag nag-move siya sa right, okay, what we'll do here is pwede tayong gumawa ng bagong vector array. So, difference in X, delta X, right? That will be, kung pupunta siya sa north, hindi mag-iiba yung X. Positive to, 0, negative 1, right? And delta Y will be 1, 0, negative 1, 0. Right? Yung explanation nito is kapag nag-move ako north, right? Walang mangyayari kay X, pero magpo-plus 1 tayo kay Y. Right? Which is tama. Kasi kung check mo to, right? Ito, 2, 0 yung XY. Kapag nag-move siya ng north, 2, 1 yung XY. So, I hope that makes sense. Okay? So, our next X and next Y, ito pwede na tayo mag-plus 1 dyan, I would say. Or, you know what, para consistent tayo for this tutorial, right? Gagawa tayo ng separate niyan. So, for X1, 0, negative 1, 0. Right? So, essentially, shift lang din lahat. Right? So, nag-plus 1 modulo lang tayo. Right? Pero yeah, for the sake of this tutorial, right, we're gonna do this. Right, so next X is equal to right wall dxr and yung ating current direction. And yung right wall dyr ating current direction. Right? And then, re-register natin siya dun sa graph natin. Right? So, bidirectional. So, what we'll do here is graph our current X, current Y, append, right? Magdadagdag tayo ng bagong entry dito. Next X, next Y, and I will also place here yung direction that we need to move. Right? Likewise, sa kabila, I'm thinking kung re-register ko na siya sa kabila right now. Pero, let's not do that. Right? Pwedeng wag muna natin gawin yun. Right? So, that's one way of doing this. Then, mag-move siya, update, and then next na yun. Right? And for the other one is kung kaya niya mag-move dito, right? Instead of right wall here, we're just gonna do this. Right? And then forward direction tayo doon. Right? And kapag natapos na siya dito, right? If current X is equal to origin X and current Y is equal to origin Y. Right? So, dito tayo papasok. Paano natin te-test kung tapos na siya sa graph. Right? Kaya hinintay ko muna to bago ako maglalagay nung pang-check nung visited. Right? Be-break natin siya. Right? So, matatapos tong while loop. And then, para to check, we could also print yung graph natin. Right, quick print. Okay. So, to check naman, right, so visited, isa siyang ganyan, for x in range size. So, yung catch nito is meron tayong 2D list, right? And what we'll do is gagawa din tayo ng maliit na function na def is whole graph is whole visited, right? Size equals length visited. We're assuming this is going to be a square, right? And hindi, we could just do this. So once na may nakuha siyang false, magre-return na lang siya ng true. Ay, magre-return na siya ng false. Otherwise, malinis. So if current x, right, if is whole visited, yung ating visited array, right, we break it, right? And we will mark yung current niyang visited as visited. I mean, yung current niyang position as visited. So current x, current y equals true. Right? Okay. We can try and do that. Right? So dapat hindi ito nag-harvest ng treasure. Tatraverse na lang yung maze. Right? And I think nag-error na. Mali. If not val. My bad. Yan. So, tatraverse na yung graph. Around dito siya nag-start. Right? Baka makita nga natin mag-pause na onte habang check niya yung buong visited graph. Right? And para sa kanya, tapos na to. Right? So, for example, tao 0, 0, yung posible niyang puntahan is itong 1, 0 east. Right? So, pupunta siya kay 1, 0 through east. Or 0, 1 sa north. Right? Ito mali ito. 0, negative 1 south daw. From 0, 1. Eh, hindi naman siya pumunta ng south eh. Ako pala yung mali. Ano pala to? Kailangan natin makuha yung, ito yung ano natin, dx dy. Sorry. Dx dy, dx dy. Tatawanan ako ng mga friends ko na ito. Next x will be next x, next y, current x plus dx, current y plus dy. Right? Yan, ganyan. Everyone nagkakamali. Don't worry about it. Okay. So, ito yung output na text na buo. Right? So, 1010. Hanapin natin yan. Meron ba tayo nun? Oh, wala. Ayun. So, 1010. Right? This is 1010. Dapat we're expecting 10, 11, and 9, 10 as valid positions. Right? So, 9, 10 west and 10, 11 north. I think that's roughly good. Okay. One more test, i-print natin yung origin. Right? Just to check na hindi tayo dumodoble kay origin. Right? Okay. Ito daw si origin. Right? Pwede siyang punta kay 6, 7. That's a beam. Pwede siyang punta kay 6, 7 north. And pwede siyang punta kay 6, 5 south. And does it look like dumodoble siya? Right? So, now, paano tayo mag-BFS? Right? Paano tayo mag-breadth first search? Right? So, an explanation, right? May graph tayo. Sabihin natin ganito. Let's make it simple. Right? So, sabihin natin dito tayo nag-start. Right? Breadth first, by the way, breadth. Right? Which is essentially parang width. Yan. Right? In contrast to depth first search, DFS. So BFS and DFS. Right? So depth, alam naman natin yung breadth lalim. Yung breadth is yung lawak. Right? And yung depth is yung lalim. Right? So breadth first search, gagawin niya, okay, check ko to. And then check ko to. And then check ko yan. Right? And then next step ko is to check ko to. Then check ko tong dalawa. Then check ko din yan. Something like that. Right? So maganda to kasi mahanap niya yung shortest path already. Right? Mahanap niya yung shortest path sa isang unweighted na graph. Right? Kung weighted graph yan, that's a different matter. Doon na pumapasok yung Dijkstra's. Right? And we're not gonna tackle this in this game. Right? Yung Dijkstra's algorithm. Right? Kasi wala naman weights yung mga items natin here. Right? So, another way is itong depth first search. So, depth first search naman is okay, ito muna, and then yun. Right? Kapag na-dead end na ako, next. O, kapag na-dead end na ako na naman, right, ito. Dead end. Right? Sabihin natin dyan. Palalim ng palalim muna. And then yan. Right? Yung catch kasi nito, if you could notice, itong graph nung map natin malaki. Right? Ilang ano to? Ano ba size nito? 12 by 12. So meron tayo 144 nito ng mga vertices. Right? So problema yon. Kung nag-depth first search tayo, it's going to like, sabihin natin 100 yung depth nun. Check na muna tong buong path and then maliit. Eh what if katabi mo lang yung treasure dyan? Right? So kaya maganda yung breadth first na essentially kung sino yung malapit, yung madaling puntahan, yun yung uunahin. Right? So sige, let's try implementing that. Meron na tayong graph. Right? Pwede rin tayong gumawa na bagong visited array. We can just make it empty ulit. And start tayo mag-BFS. So itong part na to will be gawa tayo ng bagong function, by the way. Para lang malinis. Right? So def generate maze graph. Or gawa tayong explore maze graph. So meron na tayong graph. Now how do we do a BFS? Right? So ito yung route solving natin. Okay. We're going to start sa ating origin ulit. Right? So, let's go ahead and copy that. Yung difference ng breadth first search and ng depth first search is essentially yung data structure na ginagamit for storing yung next na pupuntahan. Right? So, for example, we start here. Right? Kung breadth first search, essentially, okay, 1, 2, actually, marami to. Isin natin lahat. So, kung breadth first search to, I will make this blue. Right? And I will make this red. So, you know the difference, right? So, si breadth first, 1, 2, and 3. Right? And then, yung next niyang pupuntahan is ito, 4, 5, 6, 7, finally 8. Right? So how we do that is first come, first serve. Right? So first in will also be first out. Yeah. So first in will be first out. Check ko lang yung tamang term. FIFO. Right? So FIFO meaning niyan queue. So imagine mo nasa 7-Eleven, Jayco, Krispy Kreme, whatever ka, na may mahabang pila. Kung sino nasa una ng pila, siya yung mauna. Right? So, pinila natin tong 1, 2, 3. And then kapag na-discover natin kay 1 na merong 4 and 5, they won't cut in line. So, di nila unahan si 2 tsaka si 3. And yung depth first search naman, yung DFS, right? Ganito yung itsura niyan. So, sabihin natin 1, 2, 3, re-register natin yan, di ba? And then pag na-discover niya itong si 4, right, siya na yung magiging bagong 2. And then pag na-discover niya si 5, siya na yung magiging bagong 2 ulit. And then ito magiging 3, and ito magiging 4, ito magiging 5, right? So, it's as if may sampayan ka. Ay, may ano ka ng damit. May laundry basket ka, right? So, for a list, yung sa Python, para makapag-implement ka ng queue, may queue na library. Pero for us, gagawin natin is meron tayong list na titreat natin as a queue. Right? So, how we do that is, let's say, node queue. Right? Something like this. Okay? And then papasok natin si origin X and si origin Y. Yeah, origin X, si origin Y. Actually, hindi. I think it might be easier na we already start with origin X and origin Y. And kukunin natin yung entry ng graph. So, meron na tayong neighbors to check already. So, yung laman nito is yung next natin pupuntahan. So, hindi gagalaw yung bot natin dyan. Hindi gagalaw yung drone. Essentially, in place lang siya. Kakalculate na yung susunod niyang ruta. Right? And honestly, ayokong gawin to kasi alam ko baka i-modify niya yung original na graph. So, just to be safe, nagawa akong ganyan. For neighbors in graph. So bawat neighbor niya nandun, node queue, append neighbor. Right. So while may laman pa si neighbor, while node queue, right, habang may laman pa siya, what we will do is pop-up natin. Right? So, yung ginagawa ng pop, so ito, pop, right? Python docs. Ginagawa niya is aalisin niya yung huling item sa list kung di tayo nagbigay ng index. Right? So, aalisin niya yung huling item sa list and then dapat i-return niya rin. Right? So, what we'll do here is next to process node queue.pop and then quick print muna natin si next to process. Then play. Yeah, so yun, 6-5 south and then 5-6 west. Right? So 6-5 south, 5-6 west. Right? So now we would also like to dahil alam na natin yun, right? Idadagdag natin sa node queue yung neighbors din nun. Right? So next to process node queue pop, right? We know the X, we know the Y, and we know kung anong direction kailangan natin gumalaw. Right? Dun sa next to process na yun. Okay? Now, i-append na naman natin ulit. Right? Yung gawin natin to next X and next Y. Right? Next X, next Y. And then na-append niya yung mga neighbors sa huli ng list. Right? So this is already, well, hindi siya nag-act as a queue, nag-act siya as a stack. Right? Kasi kapag ito, nilagay niya sa dulo, and then pop-up niya rin yung dulo, first in, last in will be first out. Right? So instead, right, we would like to pop the first element here. Right? Now, paano natin to store yung directions that we need to take to get to the treasure? Diba? So, una, let's get yung target X natin. And target Y. Measure. Right? So, alam natin na yung position ng treasure. Diba? And, kailangan natin i-store yung direction so far. Right? So, in our case, naka-append na yun dito sa neighbor. Right? So, paano kasi ini-store yun? This is easier kung kung naka-recursion ako. Pero I'm doing it na naka-while loop eh. Okay, so pwede natin i-extract yung neighbor. Right. So, I think pwede natin gawin to. So, alam natin XY dear no neighbor. And then instead of appending yung raw XY tsaka yung direction, we're going to append yung raw XY and yung direction so far. Right? And in our case, dahil galing to sa origin, right? Direction so far is yung kung anong tinake niya. Right? And for this case, right? Yung direction so far, right? Will be deer plus yung next deer. Right? Okay, looking good. Right? Now, if yung next x, right, is equal to yun dun sa target x niya, and yung next y is equal dun sa target y, right, we can now return or pwede tayo mag-break, right? Pwede tayong deer to take. Deer to take is equal to deer. Then quick print natin to. And we can check it, right? So mali yung base case ko dito. Honestly, pwede kong i-start na kay origin X, origin Y. Right? Pero we can just fix that later on. Kasi may edge case tayo dito na hindi hinandle what if nandun na yung treasure. Kung nasan siya sa origin. And that happens. I've seen that happen already. Pero anyway, let's just play this for now. Ooh, expected a comma or a closing bracket. Yeah. Play. Expected a... Bakit may brackets dun? Feeling ko nag-infinite loop to . Yeah, nag-infinite loop siya kasi wala tayong visited array. Right? Kaya gumawa tayo ng bagong visited array here. Right? So, first off, ayusin ko to. Instead of doing this, I will just add yung origin mismo. And then yung deer so far will be nothing. Wala siyang tinake. Diba? Ayusin ko yan. And then what I'll do here is visited. Right? Visited x and x ny is equal to true. Now, hindi na natin append yung neighbor. Pwede natin ilagay doon kung visited na siya. Right? Pwede natin lagay yung guard doon. So, if visited tong si... Actually, parang ibahin nga natin yung naming convention natin dito. Next x and next y. So if visited na si next x and si next y, we just continue. And then pwede rin tayong gumawa ng isa pang guard here if visited na si cur x before natin siya i-assign. Kasi that means na-process na rin natin siya. Continue. Pwede ba natin nabayin yung size? Visited, current X, current Y. Bakit ka nagkamali? Index 6. Kasi dito siya sa nag-start. Yeah, instead of going to the center, let's go 0, 0. Cur X, cur Y. There. So just that we're sure. So tama, nasa 0, 0 siya. Tara, pad siya kay 3, 3. Kasi hindi ko to na iba. Play. Right, so para sa kanya, ito yung naka-calculate niya. Right, so para ma-visualize natin, I'm not gonna do this twice. right? Currently processing yung origin. No directions taken. 1-0, punta siya sa east. Or punta siya kay 0-1 north. Right? Or pwede siya punta kay 1-1. So magna northeast. Or pwede siya mag 0-2. Which is 0, yan. Breadth first nga siya. So parang may tubig ka. And then onti-onti na fill up yan. Or flood fill. I think that's another term for it. Right? 0-2. And then nag 1-2. Right? So northeast north. Right? North north north. And then northeast northeast. Right? And ito north north north. North north northeast. And then nakadetect na yung treasure. And then tapos na siya doon. Right? So now, ganun lang. Right? Ganun lang kasimple yung BFS. Now we just need to execute it eh. Right? We just need to execute it. So I would like to put this in its own function naman. Target X, target Y, node, graph. Or just graph. Here. And then quick print. There to take. And alisin na natin yung print dito sa processing. Right? Let's test this a few more times. So north, east, south, east, east, northwest, north, north, west, south, west, north. Ayun. So nakakagawa siya ng ruta doon. Right? So now we will loop this. Okay? Una explore natin yung graph. Ito is step 1. Diba? So step 1, explore the graph. Right? Graph or maze. Right? Step 2, BFS each time. Then reuse the maze. Right? So gagawin natin dito while num items.weird substance is greater than yung weird sub threshold. So gagawa tayo ng ng constant here muna. Let's say kapag we have less than 10,000, right? 10 to the 5, 10 to the 4, right? If you have less than 10,000, dun na siya mag-harvest ng gold. Right? So, kukunin niya to. And dun sa deer to take, for direction in deer to take, essentially mag-move lang siya dun sa direction na. Right? And after niya gagawin yun, magsisubstance siya dun. So, substance abuse siya dito. So, feed substance use size. And then, marireuse na yung maze. Right? Otherwise, right? Actually, gagawin natin itong ganyan. If, yan. Hangganin natin to mali yan. Else, we harvest it. Right? So, while true. So, naka-loop yan. So, we'll try this with a small maze muna. Play. Magic. Diba? Pero hindi siya ganun karami. Right? Kasi mas mabagal to eh. So yun, that works. We can harvest that muna for now. So yan, exploration na maze. On a very large maze, this is actually very slow. Right? Kasi marami siyang nire-reuse na paths. Maraming U-turns eh. Right? Medyo mabagal yung initial na Ayan, medyo mabagal siya mag-calculate to. Right? Like, it's doable now, pero it's gonna get worse. Right? Pre, I'll let this run for a bit and enjoy. Okay, I'm back. So, papag-harvest muna natin siya ng gold. Harvest ba to lahat? Kung hinarvest ko lang siya? Dapat. Kung hindi, okay lang naman. May masayang tayo ilang thousands na. Yeah, hindi niya. Hindi niya nakuha yung gold. Right? That's okay. Right? Walang problema doon. Yung gusto kasing gawin is ma-unlock natin to. Right? Dito na tayo magkaka-multiple drones. I will talk about that sa next episode. Right? Yeah, I'll just show you A-star muna para mapabilis yung BFS natin. Kasi right now, for example, nandito yung treasure. Right? And then nandito yung bot natin. No? Pag nagbi-BFS siya, nagpo-flood fill din siya pa right and pa down. Right? Which might be correct. Right? Na kunyari dun nga talaga yung path. No? Dun nga talaga yung tamang daan. No? Problema lang, hindi siya likely hindi siya optimal. Right? Yun yung sinasabi ko eh. Na likely lumalayo pa siya. Na kunyari itong right na to, yung pala magde-dead end siya doon. Right? It's much more likely na ganun and magsasayang tayo ng cycles for that eh. Right? So, one way to do that is ma-modify natin tong queue natin. Right? In such a way, nag-hold din tayo ng distance. Right? So, meron ba tayong util nun? Or navigation? Okay. So, gagawa tayo nito. So, def get distance. Right? Origin X, origin Y, target X, target Y. Right? And essentially, Pythagorean stuff lang to. Right? So, TX minus OX. No? And plus TY minus OY. And then, square lang natin siya. Hindi na natin siya sa square root. Right? Kasi para-pares lang naman yung kino-compare natin eh. Right? Hindi natin siya sa square root. Hindi naman natin kailangan yung exact distance eh. Kailangan lang natin yung parang value. Right? So, we will go here. Right? And then yung distance niya will be, of course, 0. Right? Ngayon, kapag nagdadagdag tayo ng stuff here, right? Dist. And dito sa node Q append, right? Get distance. Actually, node Q mo dito will be get distance from origin X. So, ito yung to append natin yan. Okay? Right? And then, this to target. I-reassign natin to. So now, we would like na yung nasa una ng queue is yung mababa yung distance. Yung malapit. Right? So, we are going to do a for loop instead of mag-append diretso. Kasi ano to? Reserve keyword nga pala to. So, you can't name it insert. Kasi ginagamit ni Python yung insert. Okay, 29. Tama. 3. Okay. Negative. Whatever. Looking good. Okay, so ma-modify natin tong si insert. I in range that. This to check. Tama. Baliktad to. Tagalin natin yung +1. And then return natin si node Q early. Right? Finally, pwede natin si node Q.append si to append. Then re-return natin siya doon. And hindi na natin kailangan if else dyan dapat. Play. Daming pinrint. Okay, pause muna natin. Right? Ito yung mga processing niya so far. We will see here yan, inuna niya 97 over sa 106. Right? Medyo mahirap itong basahin. Yan, 610 or 65. 58. Well, not that much yung branching paths. Right? At medyo marami ito. 65, noon is 73. So, ginagawa kasi ng heuristic is, yun nga, tawag natin dito yung heuristic, yung distance. Right? is parang medyo fino-force natin siyang lumapit doon. Right? So, alisin ko muna yung quick prints. Right? Alisin ko na yung print ng graph. And alisin ko na rin yung print nung A-star natin. So, essentially, di na to pure BFS. Minodify na natin to into an A-star. Right? So, check natin kung mas mabilis na siya ngayon. Right? Get distance. Sa insert ba? Hindi. Play. So, let's see if mas mabilis na yung route finding niya. I think mas mabilis siya. I'm not sure. Very minimal difference, I would say. Pero mas mabilis sa normal na A-star kasi gagamit ka talaga ng priority queue or you're likely sa Dijkstra's din, right? Yung priority queue kasi hindi lang siya simpleng list na tayo nag-for loop lang tayo, right? Yung priority queue, it's its own data structure. So para siyang heap, right? Or heap siya exactly, right? Yan. So implemented queues are typically implemented as heaps, right? So may sariling mas efficient na data structure for that talaga. Pero makikita natin na na-tear down na yung walls, right? And mahirap, di natin alam kung alin yung walls na na-tear down. So legit na akala ng bot may wall pa dito, iikot pa siya, right? Kaysa sa mas mabilis na ruta. So yan yung problem ng algorithm na to, sadly. Right? So we will harvest this for now. Stop natin sa next na harvest. Saan ba yan? Dito. Yan, i-breakpoint natin doon. Yan, para tumigil siya dyan. And then we will harvest that. Bro. Yan. Para mag-terminate siya. Yan. And we got a lot of gold from that. And pwede pa natin i-upgrade yung mga stuff natin dyan. Right? So yeah, that's how you do it. For now, i-limit ko to. Right? I don't think we have enough time for the other algorithm. Right? Pero yeah, we did yung right wall hugging and yung BFS or yung A-star. Right? Although medyo bara-bara lang yung A-star natin dyan. Right? Siguro next episode, I'll teach you how to memorize this para mas mabilis. Pero before that, I'm excited to handle yung multiple drones. Right? Yung parang parallel programming natin dun. How we handle that. Right? So anyway, I will just register this. Right? Right. I hope nag-enjoy kayo makita ko mag-fumble around with BFS and A-star solving a maze. Right? I'll see you on the next one. See you.